Hello and welcome back to Zig's Math Lessons. I am your host, Ziggleby Beeshtu. Thanks for dropping by. This is where we become the best science, technology, engineering, and mathematics students for miles around. So let's begin with geometric series. Geometric series. The sum of a geometric sequence is a geometric series. That's what series means. It's the sum. It's the result of adding up terms. 2 plus 6 plus 18 plus 54 plus 162 is a geometric series where a is 2, the first term, and r is 3, the result of dividing backwards. 6 divided by 2, for example, is 3. As with arithmetic series, we concern ourselves with the sums. S sub 1 means the sum of the first term. It's kind of trivial. It's 2. S sub 2 is the sum of the first two terms. 2 plus 6, that's 8. S sub 3 is the sum of the first three terms, 26, and so on. S sub 4 is 80. These sums are the result of adding up the first terms. So S sub 4 is 80 because the sum of the first four terms is 80. Here comes a formula. It's the fourth formula for this unit, sequences and series, geometric series formula. Nth sum of a geometric series is S sub n equals a times r to the n, subtract 1, over r minus 1. Let's use that formula a few times to determine the sixth sum, S sub 6, for that series, 5 plus 15 plus 45. Solution? Well, a is 5, r is the result of dividing backwards, and n, well, we're looking for the sixth sum. So n is 6. There's our formula. Plug the numbers in carefully. Calculate them out. Use a calculator if necessary. But remember, independence from the calculator would be a good thing. And it turns out that S sub 6 is 1820. Let's do it again. Let's find S sub 9 for this series of numbers. Solution? Well, a is 64, the first term. R is the result of dividing backwards. So that's 32 over 64, which is a half, or 0.5. And n is, again, the number 9, because we're looking for S sub 9. Here's our formula. Plug the numbers in carefully. Yes, you'll need a calculator here to get 0.5 to the 9th, but do it. And on the bottom, let's note that 0.5 subtract 1 is negative 0.5. The calculator told us this was negative. And when we perform this division, again on a calculator, we end up with S sub 9, 127.75. Example, determine the number of terms. That's a geometric series. Solution. First find r, the result of dividing backwards. So r is 486 over 1458 because we divided 486 by the previous term. We could have done the same with this, 2 over 9 divided by 2/3. That would have worked just as well. And in either case, we would get r equals 1/3. We know that a is 1458, but we can now find n. But to find n, which will be the number of terms, by the way, we need to acknowledge this term on the end is t sub n. So we'll use our t formula. T sub n equals a r to the n minus 1, where a is pretty clearly 1458, and r is a number that we figured out. Plugging them in, plugging everything in. T sub n got plugged in here, it's 2/9. A, the first term, got plugged in here, it's 1458. R from over here got plugged in for R. It's 1/3. Now the process of mathematics. 1458 moves over here with the 9, like this. We've seen this recently in another video, the mechanism by which 1458 divides over and joins in as a factor of that denominator. Now the 2 and the 1458 reduce. Because they're both even, we can divide them by 2, both of them, and end up there. Now, this is 1 over 9 times 1 over 729, because it would be top times top over bottom times bottom. So it's 1 over 9 times 1 over 729, but we can re-express those as this is 1 over 9, and this is 1 over 729, because 729 is 3 to the 6. So we can break this down into 3 to the 6, and break this down into 3 to the 2, and express it this way. And you'll see why in a moment. Now, when you multiply these powers of the same base, we'll keep the base, leave it alone, and add the exponent, 6 plus 2 being 8. And the reason that we expressed 1 over 9 times 1 over 729 as powers of a third is so that we could have this situation where when the bases are the same, the exponents have to be the same. If the expressions are equal, the bases are the same. They're both a third. So these exponents must be the same. 8 must equal n minus 1. And that's the magic that tells us that n must equal 9. And so there are 9 terms. Let's do another example. The 6th term of a geometric series is 972, and the 7th term is negative 2916. Find the sum of the first 11 terms. Solution. We'll need to find R and A, because look at the given information. We're given a couple of terms, the 6th term and the 7th term, but we don't know R, we don't know A, and we'll need them to find the sum of the first 11 terms. We are given n. N is going to be 11. Let's first find R by noticing that we're given the 6th term and the one next door to it, the 7th term. And we know that when we divide backwards, we get R. So if we took the 7th term and divided by the previous term, the 6th term, we'd have R. So the eye has to pick up some of these details. Like magic, R is equal to t sub 7 divided by t sub 6, because that's dividing backwards. Plug the numbers in and reduce the fraction. R equals negative 3. So we've got R. Next, we need to find A. A can be found by using one of these terms. I think I used 972. We'll use the t formula, and we'll plug in 972 to t sub n. (972) equals AR to the n minus 1, but that was t sub 6, so n minus 1 is this 5 right here. Some simple math. Now this negative 243 comes from the fact that negative 3 to the 5th is negative 243, and then divided under, because 3 to the 5th is 243, so negative 3 to the 5th is negative 243. Perform division, and we have our A value. Now we know R, and we know A. We're home free. Find S sub 11. There's our formula. We know N, we know A, we know R. Plug them all in. Carefully, notice on the bottom, negative 3 subtract 1 is going to be negative 4, and that's going to cancel nicely with that factor of the numerator. And on a calculator, negative 3 to the 11 subtract 1, because the negative 4 canceled with this negative 4. So all you need to do on a calculator is negative 3 to the 11 subtract 1. And so this scary looking problem can be boiled down to a couple of steps, and we have S sub 11. Next, example. A geometric series has 3 terms. The sum of the terms is 42. The third term is 3.2 times the sum of the other two terms. Find the 3 terms. Solution. Let the 3 terms be A, AR, and AR squared. Well, we could let them be T sub 1, and T sub 2, and T sub 3, but this sheds more light on it. We know that T sub 1 is actually A, and we know that T sub 2 is actually A times R. And we know that T sub 3 is actually A times R, which is AR squared. Now let's translate the 2 sentences into equations. The third term is 3.2 times the sum of the other 2. That becomes this. The third term is 3.2 times the sum of the other 2. And the other sentence, the sum of the terms is 42. That means when we add them up, we get 42. Let's see where this leads us if we were to multiply this out. You might say, well, how could you think of doing that? The equation itself seems to suggest that, well, we like to expand and simplify, don't we? Okay, so let's expand and simplify. Multiply it out. And there we have, looks like a quadratic equation. We've got r squared, we've got r to the 1, we've got a term without an r in it. Let's equal it to 0. By dragging 3.2 AR across to the left and making it negative 3.2 AR, 3.2A, drag it across the equal sign to the left side, make it negative 3.2A. And we have this equation equal to 0. Now, what's useful here is there's an A in each term, except for this 0, but this could be called 0A. So we could divide through by A. Divide each term by A, and we get this. R squared equals negative 3.2R minus 3.2. Now what? We could go R equals negative B plus or minus the square root of B squared minus 4AC all over 2A. That's the quadratic formula. Or we could solve it by factoring. To solve by factoring, I would like to get rid of these decimals. I would like very much to get rid of the decimals. So if we multiply by 5, that will clear the decimals because 5 times this 0.2 is a whole number. So we'll multiply through by 5. 5r squared equals minus 16r minus 16 equals 0. And here we go, solving by factoring. Well, it's equal to 0, so we're going to need the tall brackets factoring. So we're going to need the tall brackets with the 5r in the top left corner, like this. Then we have to think of 2 numbers that multiply, but not to 16. They have to multiply to 5 times 16, which is 80. So we need 2 numbers that multiply to 80 that are different. Because this is a minus sign, the 2 numbers have to be different by 16. And that's 20 and 4. Because 20 times 4 is 80, and they're different by 16. Now, we need to put signs in here and in here to get us to negative 16. So it will be minus 20 plus 4. And now we divide off what we can, and we can divide this side by 5. So we can draw a line under there and divide off 5. And when we do so, we have it successfully factored. And you can check the factoring by multiplying this out. 5r squared looks good. Plus 4r minus 20r is the minus 16r. And on the end, minus 16. So this is correct. So we've found 2. There'll be 2 series that fit the bill. When r equals 4, and when r equals negative 4/5. Let's start with for r equals 4. Sub this into the second equation, a plus ar squared equals 42. That's the other equation that we didn't work with yet. Plugging in r equals 4 and simplifying matters so that this will be 4a and this will be 16a. Altogether, that's 21a, dividing by 21, and a equals 2. So we can now say that since a equals 2 and r equals 4, there's our three terms. And we know what a is and we know what r is, so we have our series. The series is a, ar, and ar squared. That would be 2 times 4, and 2 times 4 squared. 16 times 2, 32. So that's one series. And the other one is for when r equals negative 4/5. Same thing, plug it into that. Now this is a little more tricky because it's a fraction. So this is going to be a minus 4/5 a, like this. It'll be negative 4/5 a. And this one, the r is squared. And when you square r, you'll get 16 over 25 times a. And now we have to add fractions on the left, adding fractions with a common denominator. So this a is over 1. Now it's over 25. So if you multiply 1 times 25, you have to multiply a times 25. This 5 got multiplied by 5. So 4 has to be multiplied by 5 to 20a. And this is left alone, so 16a got left alone, leaving this numerator, which when simplified becomes this numerator. Multiply 25 times 42, and we get 1050. Divide both sides by 21, we have a equals 50. Now notice, we have a equals 50, we have r equals negative 4/5. We have to plug them into a, ar, and ar squared. And the series is a, which is pretty clearly 50. AR is going to be 50 times this, so it'll be negative. And if you go 50 over 5, you get 10, so it'll be 50, negative 40. And the last term, when you square this for r squared, it'll be 16 over 25 times a, which is 50. So it'll be 16 over 25 times 50, 32. And so that's our second series. I'm Ziggleby Biestunk, and thanks for watching. If you liked it, leave a like. If you like the content, please subscribe. Check back later for updates and new videos, and I'll see you soon.